Igal, it's great to have you on the road to autonomy. Autobrains got a big deal. You got a deal with VinFast for the VF8 and the VF9. How did that deal come about?
Thank you, Grayson. So we started the journey with VinFast quite a few years ago, and they became first an investor when we were raising our Series C round. They did quite deep technical due diligence on the company. At that time, we were still early stage in terms of readiness for mass production, but the technology was quite interesting to them, so they made a decision to invest. We were in touch, and at the right opportunity, which happened about a year plus ago, there was an opportunity to basically bid on a specific level 2 program compared to the market leader in the space. So we had to prove that our solution is competitive compared to other alternatives, price wise, in terms of the hardware we are using, the sensors, but most importantly, the performance. And I think at the time we convinced VinFast in terms of performance of our product. So we started with level 2. Level 2, as you know, is a basic smart camera enabling safety features for every car, emergency braking, lane departure, lane centering, and basic comfort functions like adaptive cruise control. I think we delivered quite well milestones, so they saw it's good, and why not to try to extend the partnership to L2 Plus, which is a more interesting product. There we are talking about navigation on pilot in highway. For us as a company, it was a great opportunity to scale from using our thinking AI technology for perception to end, basically from perception to navigation, control, decision making, and provide still very low compute, vision only, affordable solution for the car to completely navigate while it's on the highway. This worked well as well. We are hitting milestones consistently. And we start to think how we can take this technology forward. Why not to push it to the limit? We've built a few cars that were driving in very complex scenarios in urban, in Hanoi. As you know, that's one of the toughest driving conditions in the world. And it worked quite well. And basically, we are taking this partnership now to the next level to productize this L2++, which does both urban and highway NOP, and can scale all the way to full self-driving for consumer vehicles, while still, again, being extremely affordable for every car. And in parallel, to use those cars in robotaxi programs where it goes beyond consumers to actually drive passengers in additional geographies.
Because Autobrains, you're known for building a highly scalable, cost-efficient autonomous driving model. And as your company says, you're the brain. You're the brain of autonomous driving.
Mhm.
From a technical architecture perspective, how did you build the brain, or if you want to call it the virtual driver, to scale from L2 system to an L4 system? How did you technically architecture that? Because did you have to build a foundational model first, knowing that where you eventually wanted to go to get to L4?
So I think one of the unique fundamentals of our thinking AI technology is what we call skills or agentic approach, right? So we have the ability to scale as we add more functionality. Unlike classical end-to-end solutions, which are monolithic model, like you mentioned, the foundational model that has to be retrained for new functionality or to be designed ahead of time, we can start from a specific ODDs, specific functionality, and then scale it by adding more agents and more skills. So the same product, the same platform that started from adaptive cruise control and started from highway can scale to urban, to navigation on pilot, to passing junctions, to very complex overtake scenarios in urban by reusing the same platform and adding additional skills, using the same hardware, the same sensors, and adding this additional functionality.
The company is based in Tel Aviv. You've tested in Hanoi before, two highly congested cities, different driving environments, different cultures, different customs.
Mhm.
Do you how do you get the system to adapt to those different driving environments, different cultures, different customs?
Yeah, one of the very important aspects of the approach is that we don't require a huge amount of data, right? So it's not a brute force approach where you need to feed millions and millions of hours. we believe that the essentials, the basics, are reusable and generalizable. It's the same pedestrians, the same cars, but at the same time, of course, there is a lot of nuances, a lot of specific driving patterns, driving scenarios, behaviors, even of regular pedestrians. And those, again, do not need to retrain, to redefine the whole architecture. It's more adding additional resources to the architecture, which we call skills, which we call agents.
It's fantastic. So you're adding new skills, and let's dive more into the technical architecture because you clearly articulated you're a vision only system.
Mhm.
Why did you take that approach? Because I look at from my standpoint, says okay, vision only, highly scalable. But
Mhm.
from your technical perspective, why did you take that approach?
So, in general, our thinking approach is heavily based and inspired by the human perception, human thinking, and overall human decision making, human driving. And as we know, the driving task was built for humans. We are using our eyes in order to understand the environment, and we're using our brains to make decisions. And so instead of trying to solve the problem brute force by more compute, more memory, more sensors, we are following the path of trying to reverse engineer the human driving. And this starts from vision. This starts from adaptive vision or active vision, where it's not just about sampling, fixed amount of pixels, as many vision systems do, but thinking about where and what to see, where to allocate the resources, and doing in a very adaptive way. So it's a merge between perception and planning and thinking and reasoning. And this allows us to be super efficient in terms of compute. It's not, processing all those pixels. Now, in terms of additional sensors, of course, it's a decision of the OEM, right? So uh, our task is to get to human level driving with vision only. And of course, additional sensors, additional compute, additional redundancies can take it beyond the human level, which is, of course, needed for many cases like robotics.
When you're working with the design team, or if you want to say the engineering teams at VinFast for the VF8 and the VF9, is it a collaborative process to determine where the cameras are going to go and what type of compute is going to go inside those vehicles?
Yes, absolutely. Especially on those projects which consider to be crazy in terms of timeline in OEM terms, we have to work like one team and to solve the problems very creatively. But even the design phase was, very, very collaborative, and it's essentially one team in order to be able to deliver such aggressive products.
How many cameras is the VF8 and the VF9 going to have on it?
So we're talking about 6 cameras. It's mostly front, uh, four side front camera, four side cameras, and the rear camera, which provides the 360. We are using our perception signature-based technology to do the fusion in a very efficient way. So essentially, the car covers the whole field of view with those cameras. And the front camera is very high resolution. So while we use low compute, we still process a lot of pixels. As I mentioned, we do it in a very adaptive way. And this gives us the ability, really to see through many complicated scenarios, urban traffic, congestions, very high speeds, heavy rain, fog. We even had, a small, very significant heavy rain during one of our tests, which the technology passed in Hanoi. So it's a very robust solution.
When you reference low compute, should we think about that from an ARM architecture, or what type of architecture should we think about that?
Today, the solution, the SoC, the system on a chip that we are using is a TI, Texas Instruments, pretty much off-the-shelf solution. We are using a classical neural network accelerators, kind of small GPUs that are running our agent, our small neural networks in parallel. And there is an orchestration process on the fly within this SoC, so we can pick the right agent for the right scenario. While we are having a lot of available computational resources, we are picking the right brain for the right scenario, and this allows it to be super efficient in terms of compute.
To me, looking at this from a VinFast perspective or from a VinFast potential customer perspective, it seems that the system's highly scalable and highly cost effective. Where if you're the end consumer, you're not looking at a ten or $15,000 upgrade to the system. Is that right to think it that way?
Yeah, this system is dramatically lower than We're talking about, as I mentioned, 6 cameras, very basic SoC. As a redundancy, there might be additional radars, but that's all. That's the whole system. Of course, as a redundancy, we are using additional layer of technology, which we call air-to-road, which doesn't add additional cost, but we are using satellite imagery, which is highly accessible today and frequently updated. So instead of HD mapping, those satellite images are being indexed as signatures and cached into the car. And where the car drives, it basically localizes itself on a satellite image in global coordinates to the level of 10 centimeters accuracy. So similar as a human being would localize himself on a map, that's how the car does that. And then as a redundancy, we get additional layers of information like lanes, construction sites, road boundaries, and many additional layers of information and traffic patterns that are coming as a redundancy from the air. So essentially, there is kind of a supervision from the air that makes their cars much more safe than just being reliant on the perception from the cameras.
It's fascinating because when you use satellite from a geographical perspective, you're not limited where you can go because satellites are covering the entire space, which gets us to, and keep going back to engineer architectural questions.
Mhm.
The over-the-air updates. Obviously, you're pushing these new coordinates from the sky, and then you're also updating the brain.
Mhm.
Did you engineer the over-the-update system? Did VinFast do it? Was it a collaborative system? And how will the brain update over time as you push new versions of the brain forward?
It's a close collaboration. VinFast is very advanced in these approaches of over-the-air update and in general the vehicle design, software-defined vehicle. So we are very happy to work with them on that. Of course, we keep this whole layer of air-to-road and pushing skills to the vehicles as part of our solution. And the idea is to be able also to work in extremely low connectivity areas, right? So where there is no connection at all. So the car doesn't need connectivity all the time. When we are moving between cities, we can update those signatures, but the signatures are so compressed so they can be stored in the car for very large areas, very large geographical areas.
So if you just look at the geography of Vietnam, so if we go from Ho Chi Minh City, for example, down to the south of Vietnam, when your system's fully deployed, no problem taking me there without any interventions.
Yes, we have today very robust performance, both in urban scenarios like Hanoi. So that's one of the most complicated one, as well as on highways where we are using this air to road, which is a big challenge to cover those very significant areas. And both of them are at very robust performance.
So you're building, if you want to call consumer performance, because I believe that over time consumers are going to demand an L2, an L2 plus plus system, and eventually an L4 system in the car. It's going to come, and you're seeing global OEMs going there, and your partnership with VinFast is going there. And the next logical step, which you announced in the press release, was a Robo-car system.
Mhm.
That's really interesting. Talk about that. Should we think about it from a design perspective? Will it be this similar VinFast designs, or how should we start thinking about this Robo-car system that you're going to develop with VinFast?
I think that the foundation are the same, right? But when we are talking about consumer cars, we still assume an intermediate phase when there is a person in the car. So the person can take control after an alert, maybe of a few minutes, maybe after a few seconds. It depends on a specific ODD and specific scenario. The idea of the consumer robocar is to give the driver time back, right? So people can actually not just take their hands off the steering wheel, but also take their eyes off the road and see emails, watch videos, but basically get the time and be productive or enjoy the time. On the robot taxi side, the idea is to take the driver completely out of the car. And regulation wise, and of course, in terms of the use case, there has to be a much higher bar in terms of redundancy. But the platform and the technology is the same. And this allows those cars that are deployed on the consumer side to be reused also for the robotaxi. That's why we call it the Robo-car. The vision is to have a similar solution, which is a mass production solution, which is affordable, that can be used for consumers, can be used for robotaxi, and can be even used for consumers to kind of add their cars into the robotaxi fleet when they're not using them. And and monetize this kind of wasted time of the car.
You hit the nail on the head because we're going to figure out the insurance liability aspects of taking your personal vehicle and putting it in the fleet, because I believe in the future, when you buy a traditional lease, I believe it's going to become a subscription, and you're going to have your autonomous driving bundled in, your charger bundling in, and then you're going to have the option to put it in the fleet, and your lease at the base price will become zero,
Mhm.
and then become a revenue generator for you. And I think that gets really interesting because the liabilities going to be figured out. Have you started to think about that from a design architecture perspective?
Yeah, I think the key to all of these use cases is affordability, right? So once you can make fully autonomous car that can still be in the range of $30,000, and the autonomous vehicle part is marginal to the cost of the vehicle, and the autonomous vehicle can drive anywhere, it's not limited to specific geofenced area, then those use cases really become possible, and that's what we enable.
And you're enabling a lot of things, and you're enabling low cost scale. How much did the agentic system that you build enabling you to scale this quickly for the cost efficiencies that you've been able to achieve?
So the idea of a skill-based and agentic system is that once we have it in the car, the additional ODD can be by adding more skills, right? If you look at today's system, essentially what you have is end-to-end systems. We call them monolithic
Mhm.
systems. The challenge with the systems that basically once they finish the training phase, they are fixed and static. They react to everything that you have on the road. And you have a new situation, a new scenario to deal with. There is no way but to take the system off the car, bring it to the lab and start retraining. The whole idea of the agentic approach is a continuous learning and continuous update over the air, which doesn't incur additional dramatic cost, right? You don't need to collect now billions of miles. Don't need to pass additional homologation on the full system. You have this granular representation of agents and skills, and they can be just added and granularly tested, and the cost would be always marginal.
Well, let's take a step back for a moment. How did you come up with the concept of the architecture for Autobrains?
So the idea was, and the inspiration was always the human brain. And if you think about the big gap today between the human capability of driving and cognitive abilities in general, and what we have today, is this gap between one giant neural network, which tries to solve the whole task at once and is pretty static after the training phase, right? There is no thinking. Once you build this neural network, you train it. I'm talking about other approaches. This neural network only has a chance to respond. It doesn't have a chance to think. It doesn't have a chance to be adaptive to different scenarios. While in contrast, if you think about the human brain, first of all, the human brain doesn't use all the neurons all the time, right? We are using every time a small piece of our brain. So this routing approach, this orchestration is key. Always to use the right resource for the right scenario. So that's how we came to the agentic approach, which starts from orchestration and routing to the right resources, right agents, and right skills. By the way, this agentic approach today became, the mainstream for non-autonomous driving AI tasks, right? Companies like
Hmm.
Anthropic are all based on the agentic approach. It's still not in the autonomous driving domain. So we believe that the autonomous driving goes through this kind of evolution from autonomous driving 1.0, which was ADAS-based systems, compound systems of perception, planning, actuation. It is now an AV 2.0, which is a monolithic end-to-end approach, and there are many companies in this domain. And we believe that Autobrains can be a pioneer in this thinking AI agentic approach, which brings the adaptivity and the thinking layer to the autonomous driving, which allows this very efficient low compute because we don't need to use all resources all the time. And most importantly, instead of trying to optimize the whole system on average, right, and then kind of missing the long tail of edge cases, we are having this divide and conquer approach where every agent and every skill can be super optimized for its specific task, which allows this additional needed accuracy and additional solution for the edge cases.
The Anthropic's a great analogy. So, I'll give you two examples. I think that the Sonnet 4.5 is a heck of a reasoning model, and Opus 4.6 is is the best coder out there, one heck of a worker. The stuff that I've been able to do in Opus 4.6 is just mind blowing. But the underarching thing that if you play enough with Claude, you can give it a personality,
Mhm.
and you can train it to understand you, to do things. And I could tell you from a workflow perspective, Opus 4.6 has made the biggest thing because it knows everything I want, all the colors and everything. Do you envision from an Autobrains perspective where you're going to give your model, your brain, the reasoning capabilities to make, say, at first low-level decisions and then eventually high-level decisions? And I'll give you an example. If you're at a crosswalk and the guard's waving you to go through and say pointing to the right, the vehicle know, okay, it's safe. The crosswalk guard is giving me the signal to go.
Mhm.
And then eventually get into higher levels of reasoning. Is that where you're going to take Autobrains?
Absolutely. So that's why we call it a thinking layer, right? So the agentic layer is step one. It's the first layer. This layer basically builds on top of the fixed model those kind of an army of optimized small drivers for every scenario. But then the second layer allows this thinking, and thinking is all about mapping the real world to those agents, to those digital twins that we can simulate on the fly and predict the different possible futures. So that's the essence of this technology, which I can elaborate more. But the idea is to have this internal model, internal computational model that is not just reacting to the environment, but it's simulating the environment on the fly, thinking about the environment, about the possible futures, which allows to go beyond the training set, allows to imagine those different futures and make a transparent, optimal decision based on the different rollouts.
Let's take this one step further here, and let's this is all hypothetical. You give the Autobrains the reasoning, the thinking level. When do we see a point where you start inputting real world weather data where the vehicle can make a decision? If you look at Vietnam, they have tropical downpours, monsoons in some cases, and the vehicle will say, okay, we know in 15 minutes a monsoon's going to stop. We're going to pull over for safety purposes and then restart when the monsoon ends. Are we going to get there at some point?
So this data is available today, actually part of our air to road solution. So these APIs are available, right? They're available to everyone, not just Autobrains. The point is that we can leverage those solutions in a kind of more personalized level. So the agent for monsoon will be a different agent than for a sunny condition, right? So those are
Mhm.
very different drivers and they can be switched on the fly based on this data.
And then that changes the game. So let's take this one step further. How about let's take it out of Vietnam and let's go to Europe where it can get cold, damp, and even snow in some cases.
Exactly. And it goes beyond even the country levels. There might be a specific zone, I don't know, a school zone where there is a specific behavior at certain hours. And the general model will be completely blind to that because it tried to optimize billions and billions of hours, and this small data was diluted. But we have a dedicated agent for this area that, of course, absorbed all the knowledge of the foundational model, but it was optimized and it was picked in the right point of time for this specific scenario. And this allows us really to get to this perfection in terms of accuracy and not stay at the generic level, which a bit converges to the mean.
If you use school zones, there's hundreds of millions of school zones around the world. How do you model for that and then also not have the bloat of all the excess data that you don't need in order to maintain the speed and accuracy of your system?
So the data that we leverage is always incremental, right? So the idea is that we keep the foundational level, which is generic, and then we train the
Mhm.
agents. Now, there can be an agent for a specific school zone, and there can be an agent for a general school zone. And they can use the same data, but this one can be optimized as long as it gets additional data for the particular school zone because there might be additional patterns. The idea is that this model allows you really to scale, right, to optimize for these narrow scenarios without paying the cost of more compute. Because the fact that you have additional agents that are not used at real time at a specific moment allows you to run a single agent, but to keep a lot of available resources. Very similar to our brain, a lot of available resources, but only small portion of them is being used for the right scenario.
So if you take the agent model, what type of latency do you need to achieve? And can you just run this over 4G? Do you need 5G? How should we think about that?
In today deployments like L2, L2+, L2++, everything runs on edge, We are just loading from city to city the different signatures of air to road. The agents and the skills are on the car. Of course, we plan to scale this platform, and we plan to soon introduce the solution that you're asking actually in this direction. But currently, everything is on the edge. And the compute that we are using is about 20 teraflops, which is mentioned, very low compute. The latency is below 20 milliseconds of end to end. So it solves the most difficult problems of high speeds and emergency braking. We have essentially two processes. One is the orchestration or the routing, which happens on a scale of hundreds of milliseconds, this kind of the context switch of picking the right agent. Sometimes it can be on a scale of seconds as well, because the environment doesn't change so much. If you're in a school zone, you still need the same agent half a second later. But then the agents that we pick are sufficient to deal with this micro ODD, and they of course are much lower compute and much more optimized for this scenario.
Because at the end of the day, it's highly scalable. So you have the public partnership with VinFast. Are there other OEMs that could be coming down the pipe at some point as well?
Yes, of course. We are working with additional OEMs. We are very happy to have VinFast as our first customer, because we believe that this partnership can bring the solution very fast and in a very broad way. So not just a specific car line or a specific product, but really the full spectrum from L2 all the way to full autonomy. And that's why we are so focused on that. But we are of course working with additional players.
With the VinFast partnership, will the Autobrains software and the hardware requirements be done fully on the factory line? So when it comes off the factory line, let's say after a certain period of time, 15 minutes, 10 minutes, the system is fully operational?
Yes, that's the idea. So the idea is, once we solve the affordability piece, the idea is that cars that are mass produced are already embedded with the right architecture to provide this full autonomy.
So you've got the consumer side there. On this side, you have the brain. Overarching, are there any limitations in terms of vehicle size or different classes of vehicles that you can deploy the Autobrain?
No, we actually are on purpose focusing on more the segments that are high volume, where the cost is a big pain, even for lower level of autonomy like L2 plus and L2 plus plus. And for these vehicles, the basic sensors, we believe that starting next year, almost every vehicle will have those sensors, right? The front, rear, and the side cameras. Some of them are parking cameras. It's part of the parking solution. So essentially, the vision of our company is to make every vehicle autonomous, right? And that's why we focus today on the volume segment and not premium cars, not luxury cars.
It's smart because then you're getting more technology into more individuals' hands. You're going to increase the driving experience by making it a riding experience. You're going to save lives and do a lot of good. And staying on the low cost angle here, that your system, no LiDAR, and I can tell you that's one of the biggest debates we have here. And why did you not use LiDAR to build Autobrains?
I think as an AI player, right, our task is to get to human level with vision only. The LiDAR should get us from human to superhuman. But if you look at the brain, and that's what Autobrains provides, those brains to the cars to drive autonomously, we must be able to get to human and above performance with vision only. And then the LiDAR should create additional redundancy for robotaxis, for additional ODDs, and so on. So that's why laser focus on vision. That's a human sensor.
I would say that's what you're focused on practicality. I have a vision only system in my vehicle and it works flawlessly. I've gone hundreds of thousands of miles with it and has worked really well and drives better than I do, frankly. Igal, this has been a fascinating conversation. Putting it all together, what is the future of Autobrains?
So I believe that the future of the autonomous vehicles in general is in kind of an inflection point now. And we will see autonomy within 5 years on the roads at mass scale, right? There is already a proof on one side from players like Waymo that autonomy is possible, unlike it was a few years ago or even 2 years ago. And then on the other hand, there is a lot of scale from very advanced ADAS system. So we have this disconnect still between the autonomy and the scale. The vision of Autobrains, what we call affordable autonomous driving, based on this thinking AI technology, is really to make these two happen in one vehicle, the scale and the autonomy, making it affordable, and doing that based on this technology that brings us a few steps closer to how human thinks.
I'll summarize it this way. Autobrains is building the brain to power autonomous driving, and autonomous driving is scaling globally. The future is bright, the future is autonomous, the future is Autobrains. Eagle, thank you so much for coming on the road to autonomy today.
Thank you. Thank you very much.